This is our third quiz on Thevenin equivalent maximum power transfer. The first question was, find the Thevenin equivalent at the port PQ of this network, like the one on the right, and that port using the 1 amp 2 amp method. We can do that. Let's do it. The first thing I do is I apply a 1 amp current source to the port PQ with that polarity and determine the value of V1A. For that I use M&A reference node, nodes 1 and 2 branch currents, arbitrarily chosen where I can, and then I write the M&A equations. All I want is V1A. How? I find V2, and V2 is going to be V1A. The M&A equations are 3, a control equation for this controlling variable, and 2 KCL equations for nodes 1 and 2. The solution will give me V1A. V2 is V1A, it's 176.7 volts. Now for the second part, I replace this source by a 2 amp current source, and the voltage will be V2A. This source, 2 amps, will replace this 1 amp source. I solve the circuit again, this time for V2A. This time, the solution is V2 is V2A, and that is 186.7 volts. Those are the first 2 answers of our question, and I enter them in my answers. Now we need to find Thevenin and Thevenin with those 2. That is, we need to solve this system of equations. The values are 166.7 volts for Thevenin and 10 ohms for Thevenin. If you wrote only 10 with no decimals, that's okay. The marker will still mark that as a correct answer. Now let's go for the maximum power that can be extracted out of that port. To compute that maximum power, we refer to the Thevenin equivalent of the circuit at that port, the circuit that we obtained already. We need to connect here a load, we know a resistor, right? That has such a value that will extract maximum power out of that, that is 10 ohms. The absolute value of the Thevenin equivalent. And we want to know what is the power. Well, the voltage will be a voltage divider of 166.7 between 10 and 10. That is half of 166.7. That is this voltage, 66.7 divided 2. And the power, V squared over R. So that maximum power is no other than 166.7 divided by 2. All of that squared divided by 10 ohms. And that is the maximum power. That is 694.70 watts. That is the maximum power. We write it down, and we're done with question 1. For the second question, we're told for a circuit that has only independent sources, the Thevenin resistance was already determined. It is 7 ohms. And the 1 amp test gave a voltage V1A of 12 volts. What is the Thevenin voltage? Enter your answer below. Well, we know that the Thevenin circuit looks like that. VTH is unknown, but RTH is known, 7 ohms. We apply a 1 amp current source here, and the voltage that appears is 12 volts. That is the configuration. From that circuit, for sure, we can find Thevenin, right? 1 amp, 7. The voltage drop is going to be 7 times 1, 7 volts. So Thevenin is going to be, well, you do a KVL equation there, and you find directly that Thevenin is 12 minus 7. That is 5 volts, and that is the answer you need to write here. You do not need to write 5, 0, 0, 0. We are engineers. We know that you mean 5. If you write only 5, that is correct. The third question, for a circuit that only has controlled sources, the 1 amp test gave a voltage of V1A, 17 volts. What are Thevenin and Thevenin? Enter your answers below. Well, we know that a circuit that has only controlled sources always has a Thevenin of 0 volts. I don't need to write 0.000. All right, 0 is okay. Do not forget the sign of, yeah, okay, the sign's okay. Now, what is Thevenin in this case? You know that in that case, yeah, if Thevenin is 0, the situation is this, right? This is your Thevenin. You know directly that is 17 ohms, right? But let's draw that. In the 1 amp test, this voltage V1A, which is 17 volts, and the voltage here is 1 times R Thevenin, tells you directly that I Thevenin is 17 ohms, and that is the answer. The last question of the exam says, if you see a classmate doing his homework and finding the Thevenin equivalent of a circuit using a two current sources method as seen in class, but when you look at his paper, you notice that he didn't use 1 amp, 2 amp. No, he used two other different current values. What is he solving for VTH and RTH with the system below? If that is so, what are the values of the test currents IT1 and IT2 that he used? Write your answers below. If this is the system of equations he's using, according to what we've seen in class, and with the polarities recommended in class, of course, the current of the first test was negative 0.02 amps. You can write it like that. Yeah, negative 0.020 amps, or you can write directly negative 20 milliamps. Both answers will be graded correct. You don't need to add the extra zeros. We engineers never do. And the second current is 2 milliamps. 2 milliamps. Or you can write 0.002 amps, and that is also correct. And now let's go for the bonus question. This was not part of the exam. This was a bonus question. 10 extra marks for those of you who wanted to try it. There is no penalty in that one. Already the other ones carried the 100 marks of that quiz. The bonus question said, an ideal op-amp is run from a plus 14, negative 14 power supply. It doesn't have negative feedback, and the inputs are VP is 3 volts and VN is 2 volts. What is the output voltage of this op-amp? Enter your answer below. Well, there is no negative feedback, so that tells us immediately that if there is any input applied to the op-amp, for sure it's going to be saturated. VP is greater than VN, so that means that the output is going to be the positive saturation one. In this case, positive 14 volts, and that is what we write, positive 14 volts. And that is all for now. Thank you very much, and I hope to see you in class.